Okay, in the next video, in this video we want to talk about how we can calculate the uh, the amount of water in the tank at time t equals 3. So we have our function, which is f of t, and we have that's the rate at which water is entering, and we have g of t, the rate at which water is leaving. So we really have f of t minus g of t, and if I opened up the calculator, and I have f of t in there already. If I wanted to put g of t as a second function, 250, then I would put vars y vars function y1 minus vars y vars function y2, and you could just as easily have done this with just subtracting 250 from y1. And now what I want to do is I want to take that integral from 0 to 3 and add that to 5,000. So I go outside and fn int, that's math, option 9, vars y vars function y3. My variable of integration is x from 0 to go back from 0 comma 3, close parentheses, and I get 126. So I have a net increase there because I subtracted the water that was taken out. I'm going to add that to 5,000. Add that to 5,000, and I get 5126.59, or 591. So you may not be able to tell this by sight, but the amount of water that was taken out from 0 up until 1.617 is less than the amount of water that was added from 1.617 up until time t equals 3. So we have a net gain over the time period from 0 to 3. Now for time t equals 7, we're going to do a similar thing here, only we're not going to subtract 250, we have to subtract 2,000. So I'm going to go back into my function. Instead of 250, I'll just write over that this time. And now I want to take the integral of that from 3 to 7. So I'm just going to do a second answer. Now I want to recall, which is second enter, second enter, second enter. Alright, now I have my function there, and instead of going from 0 to 3, I want to go from 3 to 7 this time. And there you see I have a decrease, a net decrease. You can see that the area under the red to the left of 5.076 is much greater than the area to the right of 5.076. So, but now the point is here, I'm not going to add that to 5,000. I'm going to add that to my total at time t equals 3, which was 5126.591. So I'm going to add that to 5126.591, and I come up with 4513. So you can see clearly then that the maximum amount of water in the tank is at time t equals 3, and that's 5126.591. And so I conclude by saying the amount of water in the tank is at its greatest when t equals 3. At that time there are approximately 5,127 gallons of water in the tank. So once again, to do this we had to look at the critical values and the endpoints. And the critical values, and remember that the amount of water is continuous on 0 to 7, so we're guaranteed an absolute maximum by the extreme value theorem. And we looked at the places where the derivative was 0. Those happen to both be relative mins, and we looked at the place where the derivative didn't exist, which was at t equals 3, which we have to consider, and we calculated the values of the volume of the water in slightly different ways from 0 to 3 and from 3 to 7. So that does it for this problem.